We're going to be looking at 7.3 angle-angle similarity. Let's talk about similar first. We got the elf here. They're all different heights and sizes. So we need to figure out what is exactly, how are they similar, and are any of them similar to each other. So to figure out something similar, they need to be proportional to each other. So if I compare 1 to 2, 2 is shorter and wider. Is the height and width proportional to the height and width of the first elf? Not really. If we look at the second or the third one, it's tall and skinny, so it didn't change size in the same proportion. And if we look at the fourth one, it's taller and wider, so it got bigger in a proportional matter. So, in a proportional way. So, let's look at those two. Now, let's prove that they are similar. Okay. For one, I have their height. One is 4 foot, one is 6 foot. And then I have how wide they are, being 1 foot wide and 1.5 feet wide. And then I have some triangles drawn on some of the angles that make up their elbow and their hat. So for them to be similar here, that means those angles are going to be the same for their hat. So if I move this angle over and put it on his hat, it should fit. And if I take this angle off his elbow and put it on this guy's elbow, it should fit, just cover up more space. So I have two angles that are equal, so it should make these two guys similar. All right. You can also set up a proportion with these guys by using their side links. So if I said 4 foot to 6 foot and 1 foot to 1.5 feet, if I multiply excuse me, I'm thinking of the wrong thing here. So let's go back. If I set up a proportion 4 to 1 and 6 to 1.5, okay, if I divide 4 by 1, I get 4. If I divide 6 by 1.5, I get 4. So these ratios or fractions are equal, so that makes those two elves proportional. Okay. All right, let's go on to the next page here. All right, so there's the first page of your notes. Angle similarity. It says similar figures have the same shape but have different sizes. Two triangles are similar if they're corresponding angles. That means the same angle on the other triangle are congruent. Congruent is just equal. And the lengths of their corresponding sides are proportional. So the angles have to be the same and the side lengths must be proportional. So we're going to use the angle similarity postulate. The two angles of one triangle are congruent to two angles of another triangle, and the triangles are similar. So what are we going to do to work problems out for homework? It's going to give you two different triangles. It's going to give you measurements of the angles. You need to compare those angles. All right, I have one angle here. Those are the same. But is 45 the same as B? Don't know. Is 35 the same as A? I don't know. But I do know how to figure out how to find the measure of angle A and B. I'm going to do that by adding up the two angles I have and subtracting it from 180. That's what this example shows. So let's do one. So if I have 70 and 58, I got 70 and 49. I know I have 70. So there's one angle the same. So I need to see if I have another one. So 70 and 58. All right, that equals 128. Then I take 180, subtract the 128. And if I do that on a calculator, 180 minus 28 is 152. Sorry, I must put in my calculator. 180 minus 128 is this is 52. All right, do I have a 52? Not there. I don't. So I need to do the other triangle to figure out. So I'm gonna do 70 plus 49, and that's gonna give me 119. And then I'm gonna subtract that 119 from 180, and that's going to give me 61. So the other measurement here is 61. So do I have two angles that are the same? I do not. So that makes these not similar. Okay, let's go to the next example here. I have 65, 55, 65, 60. So I have 65 and 65. So let's figure out if I have two other sets that are equal. So 65 plus 55 is 120. Take 180, subtract 120, and you get 60. So this one's 60. So that's 60, and that's 60. So that means those two are equal. I have two angles that are similar, so I don't need to keep going. So these are similar. Okay. All right. Next example. I've got the 110 and 110. All right, those are the corresponding angles. We've got this 20 and nothing there, and 50 and nothing for the other one. So I need to figure. Let's do the math here. 110 plus 50 equals 160. 180 minus the 160 equals 20. That one's 20. 20, 20. Two angles. They're similar. Okay. All right, the next one. This is where it can be a little tricky. We have to use our parallel cut by transverse rules. So if we'll just look at this first transverse right here, don't pay attention to the other one. Okay, let's just look at this first transverse, and let's just do angles for it. 30, that makes this one, that's 30, and this needs to be 180, so that's 150. 150. All right, so now let's transcribe these down here where they go. 30, 30. If that's 30, then this is 30. Okay, and that makes that 150. And these 150s aren't really relevant, but just so you know. Now let's do this other transversal in red. Okay, if that's 70, then that's 70. That's 110. So let's go over here, use our rules. See, this is same side interior. Or equal one, so that's 110. So that makes that 70, 70, 110. So I have two of the angles now. Two of the angles. I have 30, 30. And I have 70 and 70. So I have two angles that are the same. I didn't have to do any calculations. So this is similar. Okay. Going on to the next. The next is going to be proving or using proportions to see if triangles are similar. So similar triangles have two sets of congruent angles and proportional side lengths. When triangles are similar, you can set up or solve a proportion to find the missing side length. The proportion is two equal ratios or fractions. Okay, separated by an equal sign. So these are the instructions how to set it up. If you follow those instructions, you can set it up. So the first one says take a side length from the first triangle and put it over the corresponding side of the length of the second. So if I look at this example here, it says take the one side length and then put it over the corresponding side. So I'm taking this side, put it over the corresponding side, which is this side. Use these little markers here to be able to tell. This is between the 1 and the 3 arch in the angles. That just tells you that angle goes with this angle, and the 3 arches tells you That 3 arches goes with those 3 arches. So I'm looking at the side the side length that's between 1 and 3 arch marks. So that's 72 and 12. So I'm going to put 72 over 12. Now I'm going to go to 84 and x. So 84 over x. Now I'm just going to cross multiply. 72 times x is 72x. 12 times 84 is 1008. And then I'm just going to solve this by like a one-step equation using opposite operation. And you get x equals 14, and the label is centimeters. So you found the other side. Now let's do some for ourselves. So on the first one here, I have 49, 28, x, and 8. So corresponding sides, 49, it's obvious, goes with the x, the way they're turned. You can tell. Sometimes you won't be able to. You'll have to use those little arch marks. Equals 28 over 8. Now, you'll notice I put everything from this first triangle on top, and everything from the second triangle on bottom. You can't have one thing on top from the first and then something from the second one on top. They have to be, the first one all has to be on top or on bottom. It has to be the same throughout. So now I'm going to cross multiply. 28 times x is 28x equals 49 times 8 is 392. Then I'm going to divide both sides by 28, and x equals 14, and that would be meters. All right, the next one, I have turned it, so we need to make sure we're looking at the right one. I'm going to look at this one that has between 2 arches and no arches, so that's 12.5. 2 arches and no arches is the x on the other one, and then on the other side it's 11 and 9.9. So now I'm going to cross multiply. That's 11x equals 123.75. Then I'm going to solve by opposite operation. X equals 11.25. And your label is inches. Okay. On the next one. These are pretty easy. We all turn the same direction. So I'm going to go 42 to 15. And 70 to x. So those are corresponding sides. Cross multiply. It's 42x equals 1050. Divide both sides by 42. X equals 25. And that would be millimeters. All right. So you're going to set up proportions for side lengths to see if 2 triangles are similar. And then you can also find if 2 angles are the same. 2 angles are the same on each triangle to prove if they're similar or not. All right. Good luck. Have a good evening.